Before we get too deep in today's lesson, I want to make something absolutely clear. Strings are not a value type. They look like value types, they behave like value types, but they are not value types. A string is a reference type. And in fact, every time we create a string, we have created a string object. So just kind of tuck that away. Keep it in the back of your head, because whenever we talk about reference types tomorrow, we will learn the difference between a value type and a reference type. So anyway, yesterday we learned some of the fundamentals about strings. We learned concatenation. We learned the escape sequences. Today we're going to look at a few more advanced features. The first being how we can find out how many characters are in a string. And by characters, I mean everything within the string. White space, alphanumeric characters, punctuation, anything that is inside of a string is a character. So we would get the entire, what's called the length of that string. So first, let's create a string variable. Very simple. I've called it name. Give it a value of John. So if we wanted to find out how many characters are in the string, of course, we could count it on the string, but we can't always do that because sometimes we don't know what the value a variable is going to have, but we can find out information about it. So we have a property called length, and every string object has a property called length. A property is just something that helps describe that particular object. So the length is how many characters are in this string. So as it is right now, the value assigned to the length variable is 4 because John has 4 characters. But if we added a space before and a space after, then that value changes to 6 because a single or any white space within a string is considered a character. So it is variable depending upon how many characters are within the string. And right now, knowing the length of a string might seem a little, do we really need to know that? But whenever we talk about loops and arrays, then we will see that the length property, or knowing how many characters are inside of a string, is actually very helpful. So let's move on and let's get a more advanced string. Let's change the variable name to foo and let's do hello world. Good old hello world. And let's imagine that we don't know the value of foo. So let's just forget that we know that it's hello comma world, and let's just wonder if it has a comma. Well, we can search a string for a character or what's called a substring, which would be a set of characters in a particular order. So we can perform this search and find out if there is a character or a substring. And we do that using the index of method. But before we talk about what index of does, we need to talk about what an index is. So let's consider our string value here. Hello world. It's 11 characters long, and each character is at a particular position within that string. So in programmer speak, we don't say position, we say index. And there's also a little weird thing here. We don't start counting at 1. We start counting at 0. And this isn't just a C# thing, it's for many other programming languages. PHP, JavaScript, C, C++, Java. I can keep naming programming languages where you start counting at 0. So if you were going to count to 10, it would be wrong to start at 1. If you're going to count at 10, you would do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there you go. So the index of the H in our foo string is index 0 because we start at 0. So H is at index 0. E is at index 1. The first L is at index 2. The next L is at index 3, and so on and so forth. So since we have 11 characters inside of hello world, the D is at index 10. Because we start at 0. So think about what it would be for us normal people, from 1 to 11, and then subtract 1 from it, and then you have your index. So whenever we use the index of method, it's going to search in that string for whatever it is that we specify. If we want to search for an E, it's going to give us the index of that E. So let's do int index. And we are going to get a value of 1. So let's write this to the console. console.writeLine, and we'll write index. This will give us an index of 1. There we go. So if we wanted to get an index of, let's say, comma space, we could do comma space, and it's going to give us the index of where it finds this string. So let's go ahead and count this out first. H is 0, E is 1, L is 2, L is 3, O is 4. The index of the comma is 5. Now it's going to find this pattern, comma space, at index 5, so it's going to return 5. Now do keep in mind that we are searching for a string that has a comma followed by a space. If we change this pattern to comma A, it's not going to find that pattern because our string contained within foo does not have a comma followed by an A. So index of is going to return -1. And that is because -1 cannot be a valid index. Indexes start at 0, and then they can be a positive number. They cannot be a negative number. And we won't get -2 or -3 or -4 or anything like that. We are just going to get -1 if index of cannot find either the character or the string that we have specified. Now let's look at another example. Let's say we want to find the index of L. Well, this is going to give us 2. Because H is 0, E is 1, L is 2. But what if we wanted to find the next L? Because the index of is going to return the index of the first instance of whatever it is that we want it to find. So it found the first L and it returned that index. If we want to find the second L, we have to use what's called an overload of the index of method. And it's a different way that we can use the same method. It works the same way, but we provide it different information so that it can execute just a little bit differently. So we can specify the value that we want it to look for, but we can also specify from where we want it to start searching for. So in this case, we want it to start looking after this index of 2. So we could do foo.indexOf L, and this call to index of is going to return 2. So we actually want to start on index 3, because if we give it a starting position of index 2, it's going to find the L at index 2, the first L. So we want it to start at index 3. So let's just break this up a little bit easier, so hopefully it's a little easier to see. We are calling index of, and we are searching for L, but we want to specify a different index to start at. So we get the first index of L, which is 2, add 1 to it, so it's going to start looking at index 3. So whenever we run this code, we will see 3. Now there's also a similar method. Instead of index of, it's last index of. And it searches from the end of the string going towards the left. So in this case, it's going to start looking at D. It's not going to find an L, so it's going to look at the index next to D, and it will find one and return it. So it starts at the right and goes left. The index of starts left and goes right. So whenever we run this code, we will get the value of 10, because this L is at the index of 10. String objects also have tools to extract substrings from a larger string and assign those to new variables. Now, it's not going to modify our original string, but it's going to copy whatever it is that we tell it to copy and then assign that copy to a variable. So let's look at how this works. Let's create a new variable, call it bar, and the method we are going to use is called substring. And we provide it a starting index to start at, and it will start at that index, and it will go to the rest or to the end of the string, grab everything, copy it, and assign it to bar. So if we wanted to extract the word world, we would have to start at index 7, and in this case, that's all that we need to do, because it will start at index 7 and copy everything else until the end of the string. So let's write the value of bar in the console, and we should see world. There we go. Now, there's another version of substring that we can use, and that's going to specify the length of characters that we want it to extract. So if we wanted to only grab the first 3 characters of world, we would specify 3, because it's going to start at 7, and then it's going to get 8, and then 9. That is 3 characters, and that's what we would get assigned to the bar variable. So let's run that, and there we go, WOR. So index of allows us to find a particular character or string and returns the index that it was found at. The substring method allows us to extract portions of a string and assign that portion to a new variable without modifying the existing string. But we're not done. We can remove one or multiple characters from a string. Now, it's not going to modify our original string. It's going to make a copy of it and then modify that copy and then return it. So the method that we want to use to remove is aptly named remove. And it too uses indexes. So you can see that the last index and the index of methods can be handy if you need to search for a particular character or substring that you either want to extract using the substring method or remove using the remove method. So let's say that we want to remove the hello, the comma, and the world. So to do that, let's pull IntelliSense back up. We would want to use a starting index of 0. Now we don't want to use this particular overload because if we just specify 0 and call this, it's going to remove everything within the string because it's going to start at 0 and then remove everything until the end of the string. So we want to give it the amount of characters that we want it to remove. Well, how many is that? Well, let's count them. 1, 2, 3, 4, 5, 6, 7. So we will put in 7. So we are removing 7 characters starting at index 0. So the value that is being assigned to bar is going to be the world word, and then that is going to be displayed in the console window. And there you go. And just to show you that foo has not changed, well, let's go ahead and print out both of these. So we are printing foo first and then bar. And we'll see that foo is still hello world, and then bar is world. The last method that we are going to look at today is the replace method. And it does not use indexes. We provide it an old value to look for. And if it finds that old value, it will replace it with the new value that we specify. So if we want to replace the L's within our string, and by the way, the replace will remove everything that it finds. So we are searching for L. It's going to replace all 3 L's with whatever we specify. Let's do an R. So whenever we run this, foo still contains hello world, and then bar contains hello word. Kind of did that bad, but oh well. And we can also use the replace to kind of simulate the remove method. Earlier, we removed the hello, comma, and the space using the remove method. We could do the same with the replace. And for the new value, we would just specify an empty string, or if I were writing this, string.empty. Run it, and there we go. Hello world is still contained within foo, and world is now contained within bar. So those are just a few simple ways that we can manipulate strings. Now, if you're going to take 2 things away from today's lesson, I would hope that they would be this. First, that strings are reference types, but they act exactly like value types. So, for example, whenever we create a string, it cannot be modified, but we can modify the value assigned to a variable. So, for example, if we wanted to change the value of foo, we would have to call foo dot, and then whatever method we wanted to do, I'm going to call replace, and then replace all of the L's with an R. So we aren't modifying the string contained in foo, but we are assigning a new value to foo. So foo should contain hello word. So that's the first thing I want you to take away. The second thing is regarding indexes, because we will talk about indexes whenever we look at arrays, and how we start counting at 0, because that is very important, especially when we talk about arrays and talk about loops.